All right. So, how did everyone do with this assignment? Okay?
I felt pretty good about it. I get a little. I have to work through thinking about the wording to make sure I know when it's a type 1 or when it's a type 2. And then
Yeah.
always getting that last statement sentence that you're supposed to write into English, making sure that I include everything that should be in that.
Yep, those are the two hang-ups I've had, really. Just making sure I had everything. Well, let's just go through it. So, number 1, the graduate management admission test is used as an admission criterion in many master's in business administration programs. The scores on the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. Determine the null and alternative hypothesis. So the null hypothesis is 520 is hypothesis equal, or the null hypothesis equal 529, and the alternative hypothesis is greater than 529.
Very good. Okay, and B is suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of the students taking the exam is still 529. Was a type 1 or type 2 error committed? And it's a type 1.
Yeah.
Yeah. Sorry.
You are fine.
So on C, it says if the analysis was done at one level, what is the probability of committing a type 1 error?
We all know you did.
I said a 1% chance.
That's what I put, yeah.
I'm like, okay, then I do. Okay, I'm okay on that one then.
Yeah, that's what I put.
Can we do D?
Sure.
The probability of making a type 2 error would we increase or decrease the level of significance?
Yes.
4-yard rush.
You put increase?
I put increase.
Okay.
Yeah, that's what I put. Good. So, number 2, a study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of the residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Answering the national standard deviation was 5. Assuming a real estate agent wants to determine if the average age of those buying investment property in his area is different than the national average. He randomly selects 15 of the clients who purchased an investment property and obtains the data shown. So A, design the study. What is the population from which the realtor obtains his data? How did he sample his population, and what is the research question? So I put that the population was his clients, and he randomly sampled them, and if the question was if the average age of those buying an investment property in his area is different than the national average.
I have all of those are the same for me except for the population. I put down as just second home buyers.
That's what I put.
I didn't have his clients as the population. I kind of put that as what he was testing against.
Yeah, that's what I put.
Oh, okay. So you guys did
Second home buyer.
Population is the whole thing. So like everyone who's buying homes, and the sample
The sample's his client. He's able to use his clients, yeah.
Right?
Okay. Thank you.
I don't know why Karina, you're kind of freezing in and out for me too. So
Yeah,
everybody else I'm okay with. But
I
yours
can see that mine isn't working very well. I don't know
Yeah.
why. My connection.
Okay, so B, the collection of the data. Name at least one way the realtor could have randomly selected his sample. So, I mean, it's just saying that it's 15 of his clients. I mean, I guess he could have done a convenient sample and just asked them to participate in his survey if they wanted to. He could have called up 15 random people out of his total selection of clients. And those are some of the ones that I was trying to go through all of the sampling, different ways of sampling that he could have done to collect the data.
Yeah. Yeah, and I think we could have all had something different. I just put simple random. He took the list from his computer and had his computer generate a sample list for him.
Yeah, I just said like that. Like on the computer making a random sample.
Yeah. So yeah, I think he could have done it a lot of different ways.
Yeah.
So good.
That one probably doesn't matter much.
Yeah.
Yeah. Okay, this next one, describing the data I got, but were you guys actually able to go in and plug the information into like SPSS?
Yeah, did you not?
I did.
I didn't do that because I was like, I don't know how to plug it into SPSS myself. I'm like, oh wow, if I need to do that in the future, I'm gonna be a little confused.
Well, they also suggested that you could use the Excel spreadsheet from the quantitative.
There you go for it.
Quantitative what?
Quantitative descriptive.
Good? You're not good enough.
How I could get onto SPSS.
So did you put it in Excel?
No, I didn't, but that was suggested last week from the tutor or something to put it in Excel. The quantitative descriptive statistics.
Okay.
Information or copy and paste it and then use up like name.
I'll play around with that a little bit. That's one thing where I was like, when they have the little tab there and I can open up SPSS and get the information from there, I know how to do that, but I'll fool around with it a little bit.
If you go in, this is what I did. If you go in and put, if you first open it up, it will give you a blank SPSS.
Uh-huh.
And then I just put in all the ages.
Okay.
Okay.
So that's like when you first open it up and you click on SPSS, then it will pull up an open blank page, opposed to when you click on an actual data sheet, then that just pulls up the whole data that's already been input. So
just put it in the blank page the same way you would in Excel.
Yeah.
Yes. Yep. Put that in the blank page, and then you can go and do the analyze and descriptive and everything from there.
Awesome. Okay. I'll do that after we're done, so I'm sure I know how to do it.
Now you know.
So. Thank you.
The SPSS. I tried to download it on my husband's computer, and for some reason it didn't work.
Yeah, I had to get my husband's help to get the SPSS in, because it had like a 32-bit download, and then there was a 64-bit, and something got confused on my computer with the two of them, and so he had to go in and I think he had to erase one. I think he erased the 32 so that the 64 could operate correctly.
Yeah, it was a process getting it uploaded, and then because it goes through BYU's portal instead of our portal, so.
Okay.
Ready?
Whoa. Making inferences.
So if we check the requirements, since there are only 15 pieces of data, what will you need to check? So I think what we need to do, because 15 is not a large sample,
Yeah.
so we need to make sure that there's a normal distribution.
Yep.
Yep.
Okay. Number 2.
Go
State the null and the alternative hypothesis. So I have the null, or the mu equals 47, and the alternative hypothesis is mu does not equal 47, and that because it does not equal 47, it would be a two-tailed test.
Perfect. That's what I put.
Yeah, that's what I put.
Me too.
So 3, let A equal 0.05. And so I put the null equals the mu, which equals 47. And then the alternative hypothesis would be anything that is different from that. Is that correct?
I had the equal sign with the slash through it.
Yeah.
So yeah, you have the right idea. Yeah, that's pretty much the same thing. But you can write it with the equal sign with the slash is 47, so it's anything but 47.
Or is that, and that's two-tail?
Yeah.
Yes.
Yeah, that's good.
Now this one I know how to do, but I kept coming up with a different z-score than they did. So, but I kept getting the same one. So you guys let me know what you did.
I figured out because I did the same thing. I ran through it like 3 times thinking, oh my goodness, what did they do? They rounded up before they got to, so they not rounded up. So instead of like 46.733, which is what we got, what the mean is up above, they only used 46.7. So they dropped the 3. And when you do that and you run it through, then you get the 0.0209.
Okay. Well, I was like, I see what they're doing, and I know how to do it, but I'm getting something different. So
it was driving me crazy. So I actually tried to work it backwards. So I went to the applet and put in the z-score of 209, and then tried to go backwards from there.
Oh, that was smart. I just kept doing the same thing over and over again, and it got me the same results over and over again.
Yeah, it was starting to drive me nuts after the 3rd time, and I'm like, you got to be kidding me. Something is not right.
Okay, so 0.3 is what you get. Is that right?
The z-score is 0. Oh wait, sorry.
Well, if you do 47 minus 46.7, then you get 0.3.
I got a negative
0.3.
Yeah.
Oh,
okay.
Yeah.
Didn't you?
I got a negative 3.75.
And I got a negative 0.2091.
Oh wait. Okay, so what did you do? You didn't do 47 minus 46.7.
I'm looking at homework. Sorry, I'm looking at a homework answer.
Oh, okay.
So my p-value was was 0.8344. So I went up and I put the z-score in for 0.2.
Are you working on 5? Sorry.
So I'm still trying to
underscore
figure out how they got that z-score. Like, I know how to
Okay.
calculate it, but I got a different answer.
So I did
but you said they
46.7 minus 47.
okay.
And that gave me, where did I put
Negative
that?
z.
I worked it out 3 times, so and I didn't do it straight down the page. I took little pieces of things to bounce around. Yeah, 0.267 divided by, no, that's not the right one, because that gave me 0.20681. So if you take 46.7 minus 47 gives you 0.3. So you're right. It gives you 0.3, and then you divide that by 1.29099, and that gives you the. Wait, no, sorry, I'm totally messed up here. Sorry, my notes are all over the place.
Okay.
Okay.
So it is -3.
So let's see. You guys keep freezing.
I just can't figure out where the 46.73, I forgot where that came from because I'm looking through the material and I'm not seeing it.
Hold on a second. Where did I do this?
Can you jump up for a second, sweetheart?
I mean, I do know how to do it. I just wasn't coming up with the same thing, so I was trying to figure out what they did different than what I did.
The other thing that I noticed is that if you use the standard deviation from the numerical descriptive statistics, you won't get the right z-score. You have to use the standard deviation in the problem up top, where it says
Right.
the standard deviation is 5.
It's 5. Yeah, that's what I used. I used 5. Okay, let me try it one more time. So
5 divided by 15. Okay. Yeah, that's right.
So the square root of 15 is 3.87298. And then 5 divided by that is 1.29099.
Mine's a little different.
Okay, and then negative 0.3 divided by
Oh, it's not good when I can't duplicate what I did.
I
This is why I end up doing it over and over and over again.
Would someone back up and start at the beginning? My brain is like so lost. I couldn't find my pen, and so I ran to go get one, and now I don't know where we are.
I mean, we're still trying to figure out how they got the answer they did. So it's just calculating the z-score with a sample mean. So the z equals the sample size minus the mean divided by the standard deviation divided by the square root of the sample number. So what I laid out is 47 minus 46.7. Now, are you doing that backward? Are you doing that opposite?
Maybe, oh gosh, that's what I'm doing. Yes.
I put in z equals,
Isn't the sample mean 46.7?
so I put in z equals 46.73 minus 47 divided by 5 divided by the square root of 15.
Mm-hmm.
That, whatever that's called. And then my answer, I got a negative 0.2091.
So I'm not sure where you guys are getting negative from.
Because subtracting from a lower, you're subtracting a higher number from a lower number. So the 46.73 is less than subtracting the 47, so it remains negative.
But isn't the 46.7 the mean?
Yeah, but you're subtracting it from the
47 is the population mean.
yeah.
And the standard deviation is 5, not the number that the other thing came up with.
Yes.
Okay, because they're different.
Okay, so explain why you're doing 46.7 minus 47 opposed to the other way around.
46.73 is the mean of the sample, and then you subtract the mean of the population.
Oh, okay. That's where I mixed up.
Wait.
I'm so bummed. I was so excited when I figured this out and got the right number, and now I'm...
So wait, I thought that this, because the
formula is x with the line over it,
not 47.
minus mu.
And mu isn't. Oh.
And mu is
Oh. Okay, I got it. Okay, I was so confused. Okay.
It's so worth listening to when you get it because it's so much fun.
So much fun.
Okay. 46.733 minus 47 over 5 divided by the square root of 15. Okay. Okay.
So now I'm confused and I'm bummed that I didn't write everything out.
Yeah, I'm still not getting what they got. So
So
now I'm even further off.
Yeah, I keep...
So did you get the square root of 15 is 3.8730?
3.87298.
Wait, 5 divided by the square root of 15?
Yeah.
Yeah.
Well, no, just the square root of 15. That was the answer. So I have the square root of 15 is 3.87298.
Yes.
Oh, mine automatically rounded up. So I got 3.8730.
See, even if it rounded up, it should be 871. Shouldn't it?
Let me use my phone for later.
And maybe it rounds up, I don't know. If they rounded up the other, maybe they rounded up this. That's confusing. When they round up and when they don't.
3.8.
That was the frustrating thing for me. When I finally got it, I'm like, oh, they just took away the 7 or the 3 from the 7.
Yeah.
Okay, what did I do?
If that makes
I'm
a
not
difference.
getting the same thing that they are. I got 0.
Yeah.
Or negative 0.20697. So it would be like 207, not 209.
See, if I go
And that's
without
what I
taking
thought.
away the 2, yeah, if I do without the 3, I get the 0.20681. But you have 97?
20. So minus 0.206, or rounded up to 207.
Yeah, that's what mine would be. Rounded up would be 207.
Okay. So then why is it different from the... No.
See, when I do it that way, then I'm getting even further off, negative 0.23237.
What the heck?
So what answer did they get?
They got a 0.209, but I did get that when I took away the point 7 instead of doing 46.7. I did 46.733. I did 46.7 and worked it through, and I got the 0.209, and I got so excited I didn't write anything down.
And I never came up with what they were getting. Like, I was close, but I never came up with that.
You know?
So I'm just trying to figure out what they did, because I know I'm doing it the right formula.
Yeah. Let's see.
So are we
She's a part of the.
doing something? Like, what? Or maybe they're just wrong.
You're all wrong.
Yes.
I did it. I got it.
What'd you do?
46.73. Don't use the extra 3. Just do 46.73.
Yeah, I feel like that's a flaw in this paper, but I bet on the test or when we do like the homework quiz that it'll be the 3 numbers.
It probably will. It probably will. But if you just
So
do
did you round any other numbers besides that one? Or
I
did
didn't
you
change
leave
anything
them?
else. I left everything else. So it's just 46.73 minus 47, which will give you a negative 0.27.
Okay.
And then you'll divide that by the 1.29099, and I wrote the whole thing out, so I did the 449, and then that gave me a negative 0.20914, and it goes on.
Oh, okay. Yeah, I got it when I did that.
I know I had figured it out. I crossed out the numbers, the 733, and rewrote just 7.
Yeah, that's what the difference is. They just rounded 2 instead of 3.
Mm-hmm.
But I thought we weren't supposed to round until we got to the answer, though.
We're
So
not.
I'm confused.
We're not.
Okay, but at
When
least
I worked
now
I went that way, but then I worked it backwards. When I worked it backwards, it took away the 7. Or I dropped something somewhere in the working it out the other way.
that's funny.
Oh, it's hot. Okay. So we got it.
Yay!
The only difference is they have a positive. You guys are getting negative.
I got negative.
Did you get a negative?
I did get a negative.
Get a
Because
negative.
they have positive.
I have to,
Did you see that?
Yes.
And that's a big difference.
Well, yeah. Well, because it's two-tailed, it's not going to make a huge difference because it's going to have the same numbers on both sides. But
Yeah,
if
I
it's
guess that's true.
if it's one-tailed, it is going to be a huge difference.
The only thing is that answer is going to be incorrect. I mean, the next answer will have the correct probability for the p-value.
Hmm?
Then the only thing I can think of is that it would be 47 minus 46.73 because that will give you a positive. But then that doesn't follow the formula.
See, that's kind of what I was thinking, because if you read this thing, it says, according to the report, the average age of a person buying a second home as an investment rental property was 47. So 47 is the mean, isn't it?
It is, but then when you go down to number 2 and it talks about the hypothesis, when it talks about the null and the alternative, it writes mu as 47. So mu equals 47. but then you look if when you look at the formula for getting the z-score, it's x minus mu. So 47 would be in that second position.
Take a gander.
Yes, you can quickly.
I'm still seeing it the other way. I don't know.
Well, you know, doing it that way though gives us the positive. So I think that's just a question we have to try and figure out. I mean, it's either negative or it's not.
I guess I'm
but
not seeing what you're saying. I'm still seeing 47 as, I don't know. Anyway, I'm still, because 46.73 is the mean that we get.
Is the sample mean?
Mm-hmm. So you add all those numbers up in the table and divide it by the number that are there to get the sample mean.
So the x, wouldn't the x be 47 though? Because 46 is the mean?
It is. So I'm looking back at the book, and it looks like the x is the original hypothesis, and then the true mean is the mu.
Yeah.
See, they weren't terribly clear on that though, and when they write, anyway.
I think the confusing thing with this problem is they don't spell it out. Like a lot of them, they'll spell it out and they'll have mu is this. And so we had to decide for ourselves which one it was.
Right.
And don't leave it to us.
In my humble opinion, this homework is flawed.
and she's stating it for the record.
For the record!
Yeah.
Oh yeah, because the teacher will get this.
Well, at least we figured out what they did. And either way, I guess if we have one like this on the test,
That's a lot.
we just have to look at how they did it.
You know what? We have some good time where we can write this problem down and bring it back up to the tutor next week.
Yeah, exactly. So, okay. All right, well, we figured that.
Yeah.
So
And then, you know, once we got that, obviously you get the correct probability.
Mm-hmm.
Right.
So that's good for the next one. So then compare the p-value to the level of significance. You reject the null hypothesis or fail to reject the null. So I put we failed to reject the null.
Yep.
So did I.
So did I.
No, criminal force not here.
shall we do the next one?
Sure.
Alternative hypothesis. And I put we had insufficient evidence.
What? For what?
So this is, I put, we have insufficient evidence that the age of the second home buyers is different in the tested area than in the national average of 47.
Yes.
Yeah. That's basically,
That's pretty much what I would do.
in similar words, what I put.
I said now. Yeah. Talk in this course. She put so much suspense into it. She's like, no, I let the face.
And then the E, the take action, or what action, if any, do you suggest the realtor take based on your statistical conclusions? I put that he shouldn't change anything. That he should just keep working with his current clientele.
Yeah, that's what I put too. Keep targeting who he's targeting.
Yeah.
All right.
Okay.
All right, do we feel ready?
You know what? I feel ready, except for that trying to figure out that negative positive, because if we get a question like that on the quiz,
Yeah.
That'll change our answer. I did work through a bunch of the assignments in the homework. I was able to work through everything except for the final question. And everything that I was working through, I was getting the correct answer, but I was doing what I was doing before, where I had the sample mean minus the population mean.
Hmm.
Do you want to go through some of the homework problems real quick and see if we understand it?
Yeah, we can do that. I made it I made it halfway through, I guess.
Okay, let me bring that up again.
So the ones that have similar ones, what is that?
The last one I worked through was the, let's see, that negative 3.75 was the last answer I worked on. Yes, Maddie. Okay, so
Sorry, it looks like it doesn't, so they didn't really spell it out very well. It was kind of vague, but this one, it's like, it shows
This one's spelled out.
with the line over it equals this, then it's not as vague, so we don't have to guess.
Yeah.
Me and Daddy. You can ask me and Daddy for help with homework.
So which problem do you guys want to work out together?
What even is this?
I'm trying to find one.
They're doing okay. Matt,
1.4. Oh, we didn't have to work out any of for the first couple of problems. The only time that we had to, it was the last two problems. I guess that's why. So I guess it's the problem 11. So it'd be 11 through 16.
Okay, so 11, that one's easy. That's just the null hypothesis equals 40.0 centimeters, and the alternative is not equal to 40.0 centimeters.
Mm-hmm.
Because it just says different than, it doesn't say greater or less. So.
Yeah. So this would be very similar. This would be a two-tailed test.
Yeah.
So for this one, I did the 39.4, which is the mean circumference found, which is so I put the 39.4 minus 40, which gave me -6, and then I did the 1.6 divided by the square root of 100, which gave me 0.16. And then when I worked that out, it gave me a -3.75.
Is that what it got on the homework?
It is what it got on the homework.
Interesting. Let's see. See, here's the thing that...
So you don't know your times tables?
The mean head circumference is found to be 39.4. So that's the first one listed. Whereas 47 was the first one listed for the mean age. So that's why I'm thinking that 47 came first.
But I mean, 40,
Does that make
40 for me,
how my
40
brain's
here for the hypothesis. You know, when we do the null hypothesis, we said equals 40 in this problem, whereas in the other one, we said that the null hypothesis equals 47.
Mm-hmm.
So they should be in the same place in the formula that we do, because they're both represented by mu. So mu equals 40 and mu equals 47. So even though 47 comes first in the problem that we just did in the preparation, it's what we used as mu. And then we didn't get 46.733 until we got the numbers that were plugged into all the stuff that was plugged in to SPSS or into Excel.
Right.
So this one gives us the circumference. So it says a simple random sample of 100 2-month-old babies was obtained. So the mean head circumference of 39.4 is only for that 100 2-month-old babies. So that's not the mean population, or that's not the mean for the population. That's only the sample mean for the 100 2-month-old.
I see. Yeah, I see that too. Well, hopefully it would give us more laid out like this, and we're not guessing.
If it's if it's in a two-tailed, it's not going to matter. But if it's the other, it will.
Yeah, that's true. Okay, so if we are looking for the p-value, then plugging that in, 3.75.
Yeah, I got a negative.
Oh, yeah, sorry. Okay, but we're looking two-tailed, so it still doesn't matter, right?
It shouldn't matter.
So I'm getting 1.7683e minus 4. Is that what you guys are getting?
Yep.
So then we have to change that because to the e to the 4th, so we need to move the Desmo over 4 spaces, right?
Yes.
Yeah.
So it's 0.0001763. Is that what your guys are getting?
No 5? Correct?
I'm not. What did she say?
How many places do we need to go over? Like how many? It says 1.0001763. How far over? Do we need to continue? Or up there? If there's a long.
So if it's e to the negative 4th, then we move the Desmo 4 spaces.
I'm saying if the number has more after the 3.
So you just start the Desmo where it's at. So you go to the left around the 1, and then add 3 more spaces.
Right. So
Is that right, you guys?
I added 4. I added 4 more spaces. So I always thought that the number above or after the E was the number of zeros that came before the decimal.
I started the decimal and then
yes.
The decimal is 1, 2, 3, 4.
Yes. So it is. You do move the Desmo over 4 spaces. That number, but where it's 1 point something, then we're just moving it. In front of the 1 is the first space. Then 1 0 is the second space. 2 zeros is the third space, and 3 zeros is the fourth space.
Yeah, I got that. I'm just sorry. I'm just thinking if we Like it gave us 1.768. If there's more after the 8, like you guys put a 3, but on the answer key it says 8. How far over to the right do we keep going if there's more numbers? Does that make sense? No, that's okay.
See, now, well, my area on the probability applet came up with exactly what the answer key shows. 1.7683 e minus 4, e to the 4th.
So on the answer key it just says 1.768. There's no
yeah, I don't have that. I have 1.768 e minus 4 on my answer key.
Yeah, that's what I was. So that's why I was just wondering how far over does it matter? Never mind. It's alright.
I guess I'm not understanding your question.
Okay.
Okay. Got it. Sorry,
Okay.
I went to the our textbook and was just counting zeros. But yes, you're correct. So you have you would write out the 4 zeros, but then you go over the 4 places.
Right. So you don't necessarily add 4 zeros, you just move the decimals 4 spaces.
Yeah. I add the zeros because then I have like a place where my mind puts the decimals.
Yeah, that works. Okay.
You try it?
Yeah.
So you guys ready for the quiz?
Yeah.
Okay, let's get started. Okay, so after we answer 1 and 2, 3 is a hypothesis test consists of 2 hypotheses, the null hypothesis and the alternative hypothesis. Which one represents the status quo? And that would be the null.
Yes.
Yep.
Before it says which hypothesis involves quality. And that one is the null too, right?
Yes.
Yeah.
Okay, and number 5 says p-value is the probability of obtaining a simple statistic at least as extreme as the one that actually was observed. Use this information to answer question 5. When computing this probability, which hypothesis do you assume to be true? That's the null hypothesis.
Yeah.
Yeah.
Page 6. Which of the following represents the alternative hypothesis for a two-tailed test? And I'm going to go with the third one. U is not equal to 10.
Yes.
Yep.
Yep.
And then which of the following represents the alternative for a left-tailed test? I put U is less than 10.
So the first one.
The girl part kind of looks like the girl from
Mu is less than 10.
Mm-hmm.
So that would be the first one on the top.
Yeah.
Right. Yeah.
Okay, and
so
then
the next one is the
go ahead.
which of the following represents the alternative hypothesis for a right-tailed test. So that would be the second one. U is greater than 10.
Yeah.
Very good. Okay, so number 9. The outcome of a hypothesis test is determined by comparing the p-value to the level of significance, or alpha. Use the information for questions 9 through 10. which relationship would result in failing to reject the null hypothesis? So let's see. If alpha is, let's see, failing to reject, would be if the alpha is greater than the p-value, which would be number 2. Is that what you guys have?
That's what I put. Because in my notes, I wrote the p-value is less than alpha, and you reject the null hypothesis.
Very good.
Wait.
Okay, good.
Okay, wait.
P-value greater than, we fail to reject. Okay, wait. Which relationship would result in failing to reject? So, but in my notes, I have the p-value is greater than the alpha. Then we fail to reject.
Huh.
So wait, wouldn't the p-value would have to be larger than the
Then the alpha.
Mhm.
And that's when you would reject.
See, I put, if p is low, reject the null.
Yeah.
But if the p-value is greater, then you fail to reject.
I think you're, okay. Yeah, let's make sure we get this correct here. So the level of significance is the number that usually stays the same, and that's the alpha.
Right.
And that's usually 0.05.
Right.
So if it's lower than that, we reject it.
Yes.
Mm-hmm.
If it's higher than that, then we fail to.
Then we fail. Right.
So p is greater than alpha.
Right.
Okay.
So the first one.
Yes. That one
Okay.
everyone else got?
Yeah, okay, yes.
Yeah. That's what
Yes.
I
Thankfully, we're talking through it. Okay, so number 9 is the first, wait. In failing to, yeah, okay, so number 9 is the first one.
Is the first one.
Which would mean that 10 is the second one because that one is rejecting the null. And
Very
so
good.
Yeah.
Very
Because
good.
if p is low, reject the null. That's what I keep saying in my head.
P is no. Oh, that's the little rhyme that they said that they used.
Yes,
Right?
that's the little rhyme he used.
That's right. That's right. Okay.
If p is low, reject the null. So.
Okay. So we just put forth that. That's good.
I don't think it's. Okay, sorry.
No, you're good.
Okay.
Okay, 11 says an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use the information for questions 11 through 12. So which of the following would be the appropriate alternative hypothesis? So it would be the average claim amount is greater than 1,500.
Yeah.
Yes.
So which of the following would be the appropriate null hypothesis? The null would be the average claim amount is equal to 1,500.
Very good.
Right. Yeah.
Then, yes, you said equal to, right?
Yeah.
Okay.
Yeah. So the first one. Yeah.
Okay. The insurance company randomly selects 40 claims and calculates a sample mean of X equals 1,650. Use this information for 13 through 15. So the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? And I put yes. Because it's larger than 30.
Yes.
Yes. So then, number 14, what theorem or law justifies your answer to the previous question? So that would be the central limit theorem.
Very good. Okay, 15 says, which of the following is the test statistic as defined in this lesson? I would say X.
Yeah. Yeah.
Right.
Because that's the sample.
Yes.
Yes. I had to think about it, but yes, you are right.
The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. Set up a hypothesis test with the following hypotheses. Null equals $150, or the alternative is less than $150. We'll use the level of significance of A equaling 0.05. She then takes a simple random sample of 36 sales receipts from her store and concludes X bar equals 144. Use information for questions 16 through 18. What these are associated with the test. 23 minutes.
Let's see.
What are you talking about?
Okay. The receipts, 150.
Random sample of 36.
Standard deviation is 40.
So what did you guys get for that?
Oh, I'm still working.
You're faster. I'm still working
Sorry.
on it.
I'll wait.
You're too fast.
I got a negative 0.9 and then 0.0000 all the way to the end, and then last number 9.
That's what I got as well.
Can you do me a favor and grab that whole thing on my guitar?
So you got negative 0.900009.
Yes.
Is that right?
Sorry, I'm gonna shut my window. Okay, so I got negative 0.9000.
Yay, consensus.
Yeah, that's what I got too. So if we round to the nearest, then it's still negative 0.900.
Yes.
Okay.
So then the p-value.
P-value.
Yeah.
So I got 0.3681.
Mine's still trying to find the applet.
So here's where I have a query then. And
So you guys got it?
I'm still, my applet's just not coming up for me.
Oh, okay.
because it's not two-tailed, Wouldn't we just take the information from the left?
Yes.
Oh, yeah, wait.
Okay.
Let's see.
Okay.
So we're using less than, so just the left side should be shaded.
Yeah. Okay.
Oh, I'm
I was
glad
like,
you pointed that out.
okay.
Okay, so 0.1841.
0.1841.
Why are we just shading the left?
184. Yes, that's what I got as well.
I'm
Awesome.
gonna have to trust you guys on that one. For whatever reason, my applet is just not coming up.
Why do we just?
Well, 3 out of 4 got it, so.
Yay! Trust us.
I trust you guys.
0.184.
I think it's coming. Wait.
But hold on,
Okay.
just so I understand. You put the p-value, you put 0.1841. Why are we just shading the left?
Yes.
Yes,
the same thing.
because the alternative is less than.
Yeah.
Oh, I see.
So, because he suspects that the average has decreased.
Okay.
So I got my applet working, and I got the same thing.
Perfect.
Yay!
Awesome. So rounding down 0.184.
Perfect.
Okay. So 18 is what inference would you make about the null hypothesis for this problem? That we would fail to reject the null.
Yep.
Yep.
Is that because
So
it's
if it's greater, we fail to reject. Yeah.
Yep. It's higher than higher than 0.05.
Yeah.
or the p-value?
Sorry, just a sec.
Hi, Karina's dad.
Oh my gosh, I just see a big blur. I don't see him.
I just hear him.
It's just blurry.
Yeah, that was my dad. He's like, he has like a meeting in the other room. I'm like, oh, let me move. But I went there in the first place to plug in my computer. I just a mess today.
Uh-huh.
Can I ask a question about the p-value? We're failing to reject the null hypothesis because the p-value is less?
No, we're failing to reject it because it's greater than the
Great.
the level of significance.
Okay. Perfect.
Yeah. So I just use his little rhyme. If P is low, reject the null.
Oh,
So if it's greater, then we fail to reject.
oh, I see. Okay.
That's going to
So
be what
that's
I go to
what
sleep
you
to
do.
tonight. You know, repeat something in your mind as you fall asleep.
Right?
That's what
Yeah.
I'm saying.
Exactly.
Number is low, reject the null. Okay, so we're on 19.
So there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? So is this one, see, this is the one where I get mixed up. Is this one type 2?
So let's see.
I thought this was type 1.
Null is true. Reject the null is type 1.
I put type 2.
Oh, you're right.
Because it's opposite.
Right?
Plus.
It's type 1.
Sorry, I lost you guys. So type 1, right?
Yeah, it's type 1.
Type
Okay.
1.
So you would get.
So if you reject the null and the null is true, it would be type 2. Hey, there's a rhyme for you.
Oh wait, I had the opposite.
Or type
Okay.
1. Type 1.
Okay. Okay.
Yeah, sorry. I was going for the rhyme. It didn't work.
It didn't work. Opposite of the rhyme.
Yes, opposite of the rhyme.
Yeah.
So if type 2 would be if you fail to reject the null and it turns out that the hypothesis is not true.
Okay.
Okay, so number 20. A researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01, which of the following will be true? So the probability of a type, wait, 1 error will increase, probability of type 2 error will increase, the probability of null hypothesis is true will decrease, his experiment will be scientifically invalid. Okay, I'm thinking out loud, but I'm thinking.
I don't want to stay up too late trying to do it all. Could you send me to finish our scenes?
I'm thinking it's the probability that the null hypothesis is true will decrease.
I would put that the probability of type 2 error will increase.
Okay, let me look at that real quick.
So the
Type 1.
smaller the alpha number, you decrease the amount of error for type 1. But the flip side to that is as you're decreasing the amount of error for type 1, you're increasing the amount of error for type 2.
That's right, that's right. Good balance, type 1 versus type 2. Yeah, that's right. I had to go back and look at the notes. Those are still confusing me some. So the probability of type 2 error will increase.
Yes.
Okay, yeah.
Okay, and then the last one is if alpha equals 0.05, commute the probability of committing a type 1 error. Does that mean that, is it asking for, like, I mean, because that would be a 5% error. The probability of a 5% error, or was it 5 in 100? So what is it asking by computing?
The most common value for alpha is 0.05. This is equal to 1 over 20. So when the null hypothesis is true, there is 1 in 20 chance that it will be rejected at 0.05 level of significance.
So I guess my question is, what is it? Is it asking for a percentage? Because it would be it would be 5%, or is it asking us to give it like a 1 in 20 or a 5 in 100?
Gosh, I don't really know what it's asking. Compute the probability of committing a type 1 error.
Hold on one second.
It's the wording that always throws me.
Right?
So, okay, let me read down a little. It's talking about that. If the alpha value, the probability of committing a type 1 error is very small, oh, maybe that's not it.
Well, if we look at the probability or the preparation assignment, number 1, part C, if the analysis was done at an A equals 1.01 level, then what is the probability of committing a type 1 error? So it's similar in wording. And here it says that there is a 1 in 100 chance or a 1% chance.
Where are you at?
So
it's on the preparation assignment that we just went over.
what number did you say?
Number 1, C.
It won't let me write percent.
It won't?
Yeah.
Will it let you write any words in there?
No.
So do we just put...
What if it's just...
Sorry, I'm dressing up now. Okay, so maybe it's just 0.05, which would be 5%.
Yeah, because that's what the probability of type 1 error is. Wait, yeah, because type 1 error would be the same, right?
Right. Because it would be 5%, but we can't put percent, so then we would write it the same way. Is that correct?
Okay.
Yeah, we couldn't put 1 and 20 in either. It won't let us do a.
Yeah. I say
A
yeah.
fraction or writing.
I think you're trying to trick us a little bit.
Taylor has a math and your
Okay, I need you quiet for a minute.
day.
Okay, so you guys feel good about those? Should we go through everything? Just make sure we all got the same answers?
Yeah. Let's just go back to
Okay.
the beginning. Make sure that we have them.
Yeah.
Yeah.
So number
So 3.
first one.
Uh-huh.
4 is also the first one, and 5 is the first one. All 3 of those are the null.
Yes.
And then this one is muted, not equal 10, so equals with a slash through it.
Yes.
7 is the first one, 8 is the
I
second.
have that Spanish house thing.
Is everyone good?
You do that Spanish
Yeah.
one?
9 is the first.
Yes.
Oh,
10
sorry,
is the second.
kind of broke up. So 7 is the first one, 8 is the second, 9
Yes.
is right.
9 is the
the
first,
first.
10 is the second.
10 second.
I got
11 is the
It's the
third.
third. Yeah, 11's the third.
12 is the first. 13 is yes. 14, central limit theorem. 15 is the first one. 16 is negative 0.900. 17 is 0.184. 18 is fail to reject. 19 is type 1. 20 is the second one, the probability that a type 2 error will increase. And then 21, 0.05.
Okay, you ready?
Hold on one second. Sorry, there's always just a last minute question for me.
Good.
Looking at 15, when it says which of the following is the test statistic, when we go through and do the test statistic, we are testing for X, but we are trying to get Z. So we're trying to run the formula for Z.
Let's see. I know there was something like that in the notes. Let me go through the notes and see.
So I found 4.2 in the notes. It says test statistic, assuming the null hypothesis.
Okay, so it says, since we know the standard deviation in this case, we can use z-score to determine if x is far from the assumed value. This is test statistic.
So where Z is the test
Sorry, one
statistic.
second. Oh, no.
Where Z is the test statistic, X bar is the sample mean. That's right.
Okay,
So
so
where z is the statistic, x is the sample mean.
okay, so we're changing 15 from the first one to Z, which is the second one. Okay.
Right.
Awesome.
Yeah.
You ready?
Okay.
Sounds good.
I don't want to let you watch.
Good job.
Awesome.
I like it so much better with 4 brains. It wasn't quite as stressful.
So do I. Ladies,
Awesome.
you guys are wonderful.
Thank
You guys are great.
Nothing feels better than succeeding together.
Yeah.
Yes, exactly. Working well.
Oh my goodness.
Awesome.
Have a good night.
You guys too. Thank you.
Hey, have a great weekend.
You too. Bye.
Mommy, I will.
Okay, 1 second, buddy.